Hey guys, hi everyone. Thank you for joining the Jamstack.net webinar. Today we have John West, who's well known in the CMS space. He'll be talking to us about how to use .NET in order to use Headless CMS and maybe achieve Jamstack. So here's John.
Thanks, Akshay. Just to be clear, I don't know Jamstack. I don't know JavaScript, React, any of that kind of stuff. So my goal is to talk about enabling Jamstack with ASP.NET for headless content management systems. So again, I'm John West. I've been in the CMS industry for about 20 years, mostly doing .NET stuff and relatively technical stuff, but a lot of different aspects of the business. I've worked for a CMS vendor for about, I don't remember, 14 years maybe, and I've worked with a few other CMS systems. And just recently made the switch to Headless last year, and spent about that year researching Headless CMS products and architectures and figuring out how to make them work with .NET. Thanks to everybody for being here, and thanks to Conabos for hosting, and for Contentstack and Algolia for giving me access to the systems. Just full disclosure, I work with a lot of CMS products, but I also do contract work for Contentstack. That's not why I'm choosing Contentstack. I chose to work for Contentstack because I like the product and the people. So that's why I'm using Contentstack. I'm not trying to market or sell anything. From my perspective, these systems are all very similar, and you need to look at the differentiating factors, and that's what Contentstack has that I don't see in some of the competition. And again, I will say I tricked you a little bit with the Jamstack title. Jamstack for .NET is well documented. So what I'm really going to talk about is ASP.NET with Headless CMS, and you'll see how that can lead to Jamstack solutions. The demo is going to be relatively minimal, highly technical. And so it's not a marketing demonstration. It's a technical demonstration of a proof of concept, not a product. But we'll talk about different CMS architectures for Headless, and the pros and cons of some of those, and implications of ASP.NET. Most of the presentation is going to be slides. Hopefully we'll have time for conversation and some good questions. So please, post your questions and be prepared to have a discussion at the end. And Akshay is going to moderate that for us. I ran out of time, and so my slides and diagrams and things like that are going to be pretty hokey. I've never done a dry run of this presentation. It's not the kind of thing you do for something you only present once. So I'm going to kind of bumble through it. So we'll go to the next slide. This is our rough agenda for today. We're going to talk about the Headless CMS metaphor and terminology in the Headless CMS space. I'll talk about webhooks and firewalls. We're going to talk about the technologies I used in the proof of concept, the architecture of the proof of concept, and then we'll do a demonstration of that. I'll talk about Jamstack, which I consider to be a misnomer, and what I would instead call the RAN stack that enables the Jamstack. We'll talk about content delivery architectures, which are the heads in the content management, the headless content management system metaphor. We'll look at the implications of having an application server in the content delivery tier, as opposed to having a static solution there. And we'll look at .NET with Headless CMS implications. So one set of implications for having an application server in the content delivery tier, and a more specific set for .NET at that layer. The advantages of that approach, some of the basics of doing .NET with Headless CMS, and the option for doing serverless. And we'll probably run out of time before we get there, but I have slides with just minor details on those issues. So we'll start with the Headless CMS metaphor. So if you're already familiar with the Headless CMS metaphor, you can go, read a social media policy or licensing agreement while we have this discussion. But for anybody that's not familiar with the Headless CMS metaphor, I think it's a really, really bad metaphor. And I think it's a really bad nomenclature for the architecture. But these are the terms that we're using. So the body is the content management system. That's where users maintain content. It serves content to the various channels through REST. And it's hosted by the CMS vendor. We don't have any responsibility for that infrastructure as a customer. We do have some administrative rights to create accounts and things like that, but we're not responsible for anything back there. The head, or really the heads, do exist. There's no such thing as a headless content management system. We can have any number of heads. What they really mean there is that the heads are managed by the customer. rather than provided by the vendor. So there's no real native APIs in the content delivery tier. We have to use REST to get data out of the CMS or webhooks or an event bus or things of that nature. So each head, which is the content delivery tier, what serves content to the public channels, can have multiple faces. So a face is basically a website or any channel. I mean, we always talk about websites because that's where customers always start, but we're talking about omni-channel, so we could have other outlets besides the website. And again, we can have any number of heads and any number of faces. I think there's kind of a term missing here, which is maybe the neck, and that would be like the developers and users that are making the system work. And you can go in all sorts of directions. Like you could have 4 heads and 3 arms that are connected to other systems, and whatever the infrastructure is could be the legs. But no matter what you do, it's a bad metaphor. So in headless, we really don't get much value out of headless unless we have SaaS. Because like I said, with headless, the CMS vendor is maintaining the body. And the body is really the expensive part, right? That's the complex piece that we don't want to maintain. That's the vendor's technology. We don't want to do a lot of complex customizations and integrations there. We can do some integrations on the front end of the body, like embed user interfaces in the CMS UI, but we really don't want to and can't touch the back end of the body. So it needs to be SaaS, or else we're responsible for maintaining that body, and that's where the real costs of a content management system are. So by having the CMS vendor that focus on that pure technology of content management, we're relieved from that responsibility, and we can focus on the content delivery tier. This is where our developers want to work. They already know how to do .NET, JavaScript, HTML, all that kind of stuff. They don't need to know anything about the CMS except, oh, it provides JSON through these endpoints. So the SaaS CMS vendor provides wrapper SDKs for its REST APIs. The CMS vendor only exposes REST and webhooks. So if we want to get data out of it, we need to call those endpoints. And if we can call those endpoints directly from our code, but the vendors typically provide SDKs for different technologies that make it easier to call those endpoints. So headless is really headless only to the vendor. They're not responsible for the heads, but the customer is managing a number of heads. And it's bodiless to the CMS customer. The customer is not managing the body. And the biggest thing is that we have no native API calls. If I'm a .NET programmer, I can use the vendor's SDK, but it's really just a wrapper for REST APIs. I'm not calling any native APIs directly. I mean, I do call the APIs, but they're not interacting on my system. They're calling REST endpoints that interact with an external system. So headless can be multi-headed. Any body can have any number of heads. You can have 0 or more heads. You could have a CMS system with no heads. I mean, I don't know what you would do with it, but you could. And I mean, maybe you put the content onto an event bus and it goes somewhere. And the heads are managed by the customers rather than the vendors. There's no default head, and the heads and bodies are communicating only over REST and webhooks. I focus on REST because that's how most organizations implement these solutions. So they have the browser is calling REST endpoints on the CMS server. I think that's a bad architecture for a variety of reasons, but that's the way most of us are doing it. So I tend to forget to talk about webhooks, but you'll see the architecture that I would use as webhooks. And any head can actually access multiple bodies. So you could have a solution that's complex and has multiple headless CMS repositories behind it and any number of other systems. So you could pull in data from a PIM or inventory management system and search and combine all that into one set of data that you send to the clients. So these are some of the terms that we use in the headless CMS industry. Sometimes entries are also called items, but the general trend is that it's an entry. And an entry is a structured record containing field values edited through browser-based user interfaces and exposed as JSON through REST endpoints. So an entry is just a chunk of data. It's some number of field values, and the CMS vendor provides a user interface to maintain those values, do the workflow and publishing. And so an entry is just a single unit of data that can consist of multiple values. That entry is based on a content type. So all of our different page types or component types, we define content types to support the data required for those components. And the content types define the fields that make up that type of entry and other properties, metadata and things like that, that define that type of entry. An asset, and some systems will use other terminology, but an asset is basically an entry based on a content type used to manage the metadata about a binary file. So if we upload an image, that creates an asset entry based on an asset content type, and then we enter metadata. Some of it's automatic, like size and width, those kind of things, URL. That kind of stuff happens automatically, and then we enter additional metadata like alt text or whatever it is that we need to enter. In a headless content management system, when we publish, we're replicating content changes from the CMS, from its work in progress environment to the CMS content delivery environment. And it also invokes webhooks. And that replication can be as simple as just updating a flag that says this version is now live. I mean, typically they're in the same repository to begin with, content management and content delivery store, and there may not even be separate stores. It could just be metadata that says which version is live or whether the item's entry is live. And the last piece is webhooks. Webhooks, the CMS uses webhooks to invoke URLs that signal events and pass data to other systems, such as when publishing content. So if you log into the CMS and publish a piece of content, if you've configured webhooks, that publishing process can signal those other systems that something has changed and pass the data to those systems. So I'm trying to keep it really simple. Obviously, there's a lot more to these systems, but those are kind of the basic concepts from my perspective. So then we get into our first problem, which is if we want to use webhooks, what do we do if we're inside a firewall? So the CMS server is out there in the vendor's cloud, and it needs to call my developer workstation, which is inside my firewall. So in the context of headless CMS, webhooks are URLs invoked by the CMS to signal events and pass data to other systems, such as when publishing content. So if we have a development, an intranet, or some other kind of protected system, it'll be within a firewall. It probably won't have a public DNS entry. So how does the CMS know how to call a webhook, how to pass that webhook data to something that doesn't have a DNS entry, is inside a firewall, and that firewall is probably doing NAT, or the router's inside it. So we really don't have a great way for that to happen. And webhooks can't get through firewalls that block the required ports and generally shouldn't use IP addresses. We want them to use DNS, and NAT creates all sorts of problems. So how can the CMS invoke webhooks on development systems? We'll get to the demo pretty quickly. I know this is kind of dry, but I need to do a little bit of setup. So there are a bunch of different options. We can open the vendor-defined ports in the firewall to specific IP addresses. And that really only works for developers that can administer their firewalls and configure DNS and reverse NAT and all that kind of stuff. So that's not a great solution in general for a developer that's working from home. We can simulate the webhook calls. So instead of having the CMS invoke the webhooks, we can basically copy the webhook, the REST API call, and then we can paste it into Postman. But that's not really, it invalidates our integration testing, because we can check if the webhook functions properly internally, but it's not really good for testing because you're not using the full system. We have an architectural approach that we could take. So instead of using webhooks, we could use polling techniques. So some CMS products include sync APIs that will give me all of the data, and then that'll set a timestamp or some other identifier, and I can pass that back and get updates. So I can do polling to find new data. But that's not going to address all of our use cases. It works. It's great for certain applications, but there are other use cases where that doesn't fit. So what I consider to be the best solution is to use a third-party tool such as ngrok, or I don't know how they pronounce that, which is going to reverse proxy webhook calls. So ngrok is sitting out in the internet. We run a process on our local host. It's polling ngrok to see are there any requests coming in. When it gets a request, it passes that on to the web server on our local host. So I just need to explain this because the demo depends on this. And there's a little bit of learning involved here. You have to learn ngrok or whatever it is. There's a little bit of overhead of running an additional process. And if you want to have persistent DNS entries, then you need to pay ngrok for it. So you can use ngrok for free, and you just have to change the URL every time you run ngrok. But basically, this makes test systems DNS addressable to the public internet, so that CMS vendor clouds can call webhooks into our local environments. So here is a diagram. I apologize for it, but you can see at the top we have the vendor's cloud, and we have two basic environments there. We don't know the internals of that, but there's a content management repository and a content delivery repository. When we publish, we're basically migrating data or updating a flag in the content delivery repository to say this version of this entry is now live or deleted or whatever it is. When we do that, if we've configured webhooks, they can call the external systems. So in the case of this demo, it's going to call ngrok, and the visitor is going to be accessing my ngrok URL. And then we've got ngrok.exe running on my workstation, and it's forwarding requests on the secure and unsecured ports to my local host. So we have to do a little bit of infrastructure to get webhooks functioning in this environment. So next we'll get into the proof of concept. We're getting pretty close to the demo, I think. So I'm using the Contentstack SaaS headless content management system, and it's not because I'm trying to market Contentstack, although I do actually do contract work for Contentstack, and we're looking at a different role for me there. But the reasons that I like Contentstack, number one, the people at Contentstack. Number two would probably be the data modeling capabilities, which are better than the other headless CMS products that I've looked at. We get a number of field types that don't exist in the other products. Each field can have repeating values. And we also have this concept of modular blocks that I don't really have time to touch on or demo, but it's a really powerful capability that doesn't seem to exist in any of the other systems. It's also got a content delivery sync API, which some of the other systems don't have. I'm not using it in this case, but it's there if I need it. And we also have the .NET SDK wrapper for the REST API. And one of the points that's not listed here is also the user interface. As I go through these systems, I find Contentstack, there's the adjustment when you're coming from any other system, but then once you make that adjustment, the UI is just more usable, then it's more easy to learn and just provides everything in one place compared to some of the others that look a little bit less integrated. I'm using Algolia for search, and I actually don't use search that much, so the demo doesn't really care what search engine it is. So it's again one of those cases where I look for capable technologies with good people that provide support. I tried a couple other CMS vendors, or sorry, search vendors, and got totally different experiences. So I ended up going with Algolia. I will mention I do think that both of these are probably relatively high on the price level, Contentstack and Algolia. But you get what you pay for in a lot of ways, and I would prefer to work with these vendors than some of the others that I've worked with. I'm also using ngrok, as I mentioned, and ASP.NET Core MVC. So, it took me long enough to make the switch from web forms to MVC, and I'm not going to Blazor or ASP.NET Razor Pages, but you could use those instead. But I think probably the audience is more familiar with MVC, and I'm totally unfamiliar with those other options. So in the content delivery tier, we're going to have an ASP.NET application server, and it's going to be hosting an MVC solution. Obviously using newtonsoft.json to process the JSON. And I intended to do a demo with React or some other Jamstack technology, but I just couldn't get there. So the JavaScript is going to amount to alert. Alert is basically the only JavaScript that I know. And so that's why that's the case. So the architecture of the demo is we're going to use publishing webhooks that trigger ASP.NET to call Algolia. So the CMS is going to pass the updated entry to ASP.NET. ASP.NET is going to pass that data to Algolia to index. And so that's going to update the index. So optimally, when the application server receives that webhook from the CMS, it would store the data locally in a cache of some sort, a persistent cache, so that it doesn't have to go to search or go back to the CMS the next time it needs that data. I actually have a working solution that does that, but it's too complicated to demo, so I'm not doing any caching. Okay, and then, so let me just say that again. When the CMS invokes the webhook on the application server, it passes the data to the index and should cache it. But instead, I'm using an ASP MVC solution, ASP.NET MVC solution that renders the data, should come from the cache, but in my case, it's coming from search. So when the URL comes to the web server from the public internet, I'm going to get the data out of the search engine. And if you think about it, every incoming request is really a search. It's a query. And so in the case of a URL that doesn't have any query string parameters, it's a query by URL. So using the same architecture, whether it's a formal query or a simple query, leaves me with less code to maintain in one solution. So I'm not going to search for this and going to content management for that and other systems. I'm also embedding the JSON in the HTML that's sent to the client. So the way a lot of headless CMS systems work, they send HTML to the client then does the REST API calls to the CMS to get the data that it needs to render the page. That has some performance implications. I get, the first hit, and then I have to go get the data. So instead of doing that, because we have an application server, we can embed the JSON in the HTML, and so scripts running in the page can access that JSON and render things dynamically without placing additional HTTP calls. Of course, that JavaScript running in the client can place additional HTTP calls, whether to the ASP.NET solution or to the CMS to get additional data, but it doesn't have to. And you really want that first page render request to be high performance. So anyway, that's we're not going to be going to the CMS to get data when a request comes into the web server. And we're going to embed the JSON in the response to the client on the first page request. And again, everybody's going to have opinions, and I'm not going to say that this is the best way. I'm just going to say that if I want a really performing website, then this is one option. So this is kind of what the POC architecture looks like. We've got the CMS at the top. That's both content management and content delivery. When it publishes, it invokes a webhook on the content delivery application server that's running. Well, it should be in the cloud or on the internet or in the perimeter, but for me, it's inside my network. So that's where ngrok comes into play. So the CMS invokes the webhook that passes data to the content delivery server. The content delivery server passes it on to search. Search indexes that data. Then when the visitor places a request against the content delivery tier accesses the data from search. So it doesn't go back to the CMS to get the data, it goes to search to get the data. And optimally, it would go to cache to get that data because the data has already been given to the application server. Why does it need to go get it from somewhere at that point? So I'm forgetting to say all of the notes I had written down. So there are a lot of ways to populate a cache. So in this case, we would be using webhooks to populate the cache or individual requests to kind of lazy load the cache, but there are a lot of other options. You could use the sync APIs to preload that cache when the application starts up. You could use webhooks that push data to messaging systems. So instead of pushing the data to the content delivery application, you could have a message bus, and then the content delivery could be subscribed for messages on that bus. We could also load the data directly from search. So instead of using the sync APIs, we could retrieve all of the data from the search when the application initializes and load the cache from that. What's really cool about that is that no matter what you do, the code is almost all the same. I'm using the same JSON formats, the same .NET classes to represent those JSON objects. And so it's relatively trivial to do these kind of things. And you can change architectures relatively easily. So mock, I don't know if anybody knows the term mock, but it's basically microservice API first, where API means REST, cloud, where cloud really means SaaS, and headless, which I don't know what headless means exactly. But so mock-like systems can share JSON formats, .NET classes, and make it easy to implement major functionalities such as reindexing all the content from the CMS. Okay, so now we get to the demonstration, and haven't ever done this before. So let's look at the solution first. Sorry. I'm just going to walk through the code so that people have some context, the developers have some context about what's going to happen. Hopefully some people are familiar with .NET. So my startup, I think, just registers a couple of endpoints. So this is going to handle the publishing webhook. So we're going to call the publish controller and the index action. Index is kind of a weird term because it's just the default name for an action. But in this case, this action actually calls Algolia to do some indexing. So it's just a kind of coincidence there. And then I know this is probably considered bad practice, but any other URL, we're going to assume it represents an entry, the URL of an entry, and we're going to, in the entry controller, call the index action. So let's maybe take a look at those controllers. we'll get a publish controller. So this is going to accept the webhook. I've got this little diagnostic tool that I use that's just going to help me dump stuff to the console when things happened. We want to get the payload, the JSON payload of the webhook. So that's just a variable that's going to hold the payload. We make sure it's not empty, just minor error control. You obviously need to secure this endpoint and do better error control than I would do in a demo. And then we make sure that it is a successful publish action. If it's a successful publish action, we convert it to a JSON object so that we can process the data more easily. This is actually extracting the entry into an object.
Hey, John, can you increase the size of the font? Yeah, there you go. Perfect. Thank you.
Happy to share this code. If anybody follows up on it, I'll pass it along. So we have action and status. This is successful publish. So at this point, we've got a successful entry published. There are other things that you would want to trap, like deletion or things like that. I don't know if you want to use a separate controller or separate webhook. It's up to you. But I'm only managing updates at this point. Then I want to pass that data to Algolia. So we create an object that we're going to pass to Algolia. Everything in Algolia, we need to give it a unique ID. And in this case, I'm going to use the unique ID of the entry from the content management system as the unique identifier of the record in the search index. We're going to have a URL property or field in the search index, which is the URL of that entry. Every entry in the CMS is associated with a URL or can be. So that property in the search index is going to let me look up entries by URL. JSON is really just the raw JSON of the entry. So you can pull out individual fields for indexing to make your queries easier. But in my case, I don't have that need. I just want to put the JSON directly into the search index so that I can retrieve that JSON from the search index without going back to the CMS. I don't want to query the search index, get some identifiers, and then go back to the CMS to do something with them. So to the extent possible, I want to always get data that I need from search if I can't get it from a cache already. And then this content type just identifies what type of record it is. So each, like we can have 100 content types. This is just setting that. So I might want to query by content type. So I just put that in there. Then we're going to pass that data to Algolia. I know this is not best practice. This is me being lazy. And then we're going to add that to a list of entries. In a real solution, you probably wouldn't necessarily want to do each entry separately for indexing. You'd want to batch them up, which is another reason to use a messaging system. So start a transaction of publishing, intercept all that data, batch it up. When that transaction completes, then pass it all to the search index. So again, just proof of concept, but you have a lot of options. This is actually calling. So again, this SDK from Algolia is just wrapping their REST API. So we're passing the JSON that we just retrieved to the search index for indexing, and then just a little bit of diagnostics, and then we're going to say return OK. So the CMS is going to get an OK if it was successfully indexed. Show a couple of models. So the search index entry, this just defines the fields we just looked at. This is the object I'm going to pass to the search index. Web page entry is really defining a content type. So I've defined a content type in the CMS. It's got a title. That's really its only property. Actually, it's got a view. So this lets the CMS user specify which view, which CS/HTML file they want to use to render that entry. And every entry has a URL and tags. Every entry also has a UID. And just for fun, I put the updated at. I don't know why. So we don't need to look at my diagnostics class. Then let's look at the entry controller. So when a request comes to the web server, it's going to invoke this controller action. And so this says, find the URL that the browser requested, then go out to that search index and look in the index named URLs, which is the one we just populated. Then go find the object in that search index that has the URL that was requested by the browser. And then if we find a request, then we want to process it. So this says, create an object of the type that we just looked at, this thing, and get it from the hit that we just got back from the JSON from the search engine. So this is basically converting the JSON that's stored in the search index to an object based on a POCO that we've defined, a plain old C object. And then we're going to return the view. We're going to view that entry. Let's take a quick look at the view, and you'll see how bad my JavaScript really is. So the view is just going to say, set the title to whatever the title property of that entry model is, and then some script that says, create a variable named by the UID of that entry, and all it contains is the JSON of that entry. So we've got a JavaScript variable that contains the JSON, and I've indented it. I wouldn't do that normally, but for debugging and demo purposes, it helps. So take that JSON and serialize it into the HTML that we're sending to the client in a script block. And then the next thing is to just do an alert that gets the data out of it. So just dump that title to an alert message. And then it's also, we're going to output the title as well as HTML. I don't know if it's dynamic or not. I mean, it's, yeah, it's not going to change, but it's not necessarily hard-coded either. So I'm not sure what that means. So try and start this up. I think that's all I needed to show in there. So this is my web server. Oops. Okay, so this is actually loading the page. So it's this is my JavaScript alert, the original entry title. So currently, the entry that has the URL of the home page, the title field is original entry title. And I can see that dynamic, and I see original entry title. If I do a view source, which I almost never do, but I'm not even sure how to do that. There we go. So, and you can see there's my JSON, and it's got properties like its UID. So we've got a variable named some GUID that is this JSON structure. And then in our JavaScript, we can do anything we want. And I know that this is not how a lot of JavaScript frameworks work, but it should give you an idea that you can do all those things. You just have additional options when you add an application server in the content delivery tier. Okay, so I need to be able to access this from the public internet. And to do that, I need to run ngrok. Let's look at what the ngrok command looks like. Find it. So this says run the ngrok executable. I don't know what HTTP means, but we're going to create a subdomain called ranstack. So it's going to be ranstack.ngrok.io, and requests to that are going to get forwarded to my localhost on 5001. So this is ngrok running, and right now we don't see any connections coming in. If I go back to the browser, and so right now it's accessing localhost. If I change that to ranstack ngrok, let's see what happens. Okay, so I can see I get slash, it forwards it to localhost. Localhost responds 200, and I get the original entry title. So I get the same thing that I would get on localhost. So the next thing I think we should do is go into Contentstack.
Hey, John, can you zoom in on the browser as well? Thank you.
So this is going to look a little funny zoomed in. The UI is actually better than what it's going to look like all zoomed in. And I do have an email address at Contentstack. I'm not trying to hide that. I do work for them. Can't remember my password though. Okay, and this is my stack. In Contentstack, you can have any number of stacks, which are basically separate repositories. So this is my stack that just had for this demo. If I look at the field types, the content types, this is the only one that I've developed. Oops. This is one of the places where I get confused in the UI because I'm used to a different approach. But I want to edit this content type to show you what it looks like to define a content type. Everything always has a title, a URL, and I've created this view field. I actually don't use this in this demo, but the user could select from a drop-down list which view they want to use to render this content item. So I only have one piece of content, and it's got a title called original entry title. Its URL is slash. This isn't actually used, but the user could select an index, and then it's got some tags. So let's just go to updated, and I'm going to save it. Before I publish it, I want to show how the webhook is configured. So this is my webhook. It says, call that publish controller. And when any entry is published to my content delivery environment successfully, then invoke this webhook. And it determines the JSON format. We don't have to tell it what to do with that. So I'll go back to content and see if I can publish that. So I made a change and I want to publish it to that content delivery environment. So I will take it and choose to publish it. Actually, I'm going to hit the publish button, but I want to see what happens over here. And here goes the publish. We should see the webhook getting invoked, and there's some diagnostics that are going to output. Oh, this one doesn't show the output. This is where the output is. When this is the web server, and it's saying, oh, here's the JSON that was sent to me. And I'm going to pass that on to the search index. So the JSON that the CMS provides has all sorts of metadata and stuff that we don't really need. So we convert that to another object that doesn't have all of those properties. And that's basically the demo. If I go back to this place, we should see my updated title on this page. And it says updated entry title. So I know that's not Jamstack. I was trying to be honest about that from the beginning, but it shows you the architecture that we can use for Jamstack, or an architecture that we can use for Jamstack applications. So I'm expecting some questions and maybe some complaints about that when we get to the Q&A session. I got to check the time. So I did the demo. So I want to talk about something that I call the RAN stack, because I think Jamstack is a misnomer. Jamstack depends on what I would call the RAN stack. So JavaScript is just one available language for using with these mock architectures. The alternatives have advantages on both the client and the server. I would rather use TypeScript or Blazor or some other WebAssembly, something other than JavaScript. So I think JavaScript is not the right technology, and I would say the J in Jamstack should really be an A, because I can use any programming language. Yeah, there are lots of JavaScript frameworks, but that doesn't really address my problems as a backend programmer. So all programming has always had APIs. REST is the real paradigm shift that enables, I mean, once you start using JSON and REST, XML looks like it was holding back the industry for decades. And so you need to switch to JSON if you're still using XML. So REST is the real paradigm shift, and let's highlight that by using an R for REST instead of an A for APIs. In these architectures, it seems like modern developers just assume that API means REST API, and historically API has always meant native API. So I think it's important to differentiate. REST and data reusability are really about JSON, not markup. So why do we put M for markup if what we're really talking about is N for notation, which is JSON? So the RAN stack uses REST with any programming language to process data in JSON notation. I just think it's a better description of the architecture and the technologies than JavaScript, and trying to suggest that everybody should be doing everything with JavaScript on client and server. So Jamstack frameworks use JavaScript and markup to implement the RAN stack, but you could use anything. You don't have to use JavaScript at all. In fact, I wouldn't. So there are certain things that you can only do with JavaScript, and others that you can do better with other technologies. So static, this is just a title that we're going to be about to look at some diagrams. The simplest headless CMS architecture looks something like this. Inside your environment, you have a build process that pushes files out to a content delivery tier. That build process can, but does not have to, retrieve media and content from the CMS. And so then you have static JSON or static HTML files in the content delivery tier that were extracted from the CMS as part of a build process. Then the visitor first requests content from the content delivery server. That gives us an HTML. Then that HTML contains JavaScript that tells it to go get some more data from the CMS. And then all throughout, there are references to media that need to be pulled in by the browser to render the page. Really looks like a simple architecture, but there are a lot of drawbacks to this architecture. I mean, if you think about how many HTTP requests are happening and in what sequence, this is not how I would architect an application. And I'm sorry to people that are doing it this way, but there are just too many advantages in other approaches. So this works. I mean, it'll scale, but it's using so much server resources and bandwidth to do really simple things that it's probably not the most efficient architecture. So again, this is a static content delivery tier. A lot of systems will have an application server in the content delivery tier. That application server is often node.js. There are other things out there like Lambda functions and things like that. So almost always there's some back-end functionality. But let's admit that and call it an application server and use the right technology at that layer, which is probably not JavaScript. So when we add a real application server, if I'll just go back and forth between these two so you can see the differences. Basically, what we're saying is the content delivery tier can now retrieve data from the CMS, from the content delivery environment. So instead of having its own copy of all the data locally, it can retrieve data from the CMS when it needs to. Oops. And if you look at the second arrow that's turning red, kind of at the bottom, it's saying that now that the content delivery application server can access the data, from the content delivery environment without an updated build process, there's really no need for the visitor to contact the CD directly. The visitor can get all of the data from the content delivery application tier with less bandwidth utilization, less HTTP requests, and for the developer, one set of technologies instead of I'm going to do this for search, I'm going to do this for JavaScript, I'm going to do this for the application server. I personally would do everything that I can in the application server. That's what it's for, is back-end functionality. Anything that I can only do on the client, I'll do on the client. So that's all I have for diagrams, I think. So some of the implications of putting an application server in the content delivery tier. So in my case, I added the ASP.NET Core application server to the content delivery tier. There really were no other changes necessary to enable the advantages, and really I don't have any drawbacks. I can still do anything that I could have done with that static architecture. So I could still have JavaScript running in the client that's placing requests directly against the content delivery environment in the content management system, but it enables a lot of other architectural approaches. So the application server can interact with the CMS and the search engine and the PIM and the inventory management system and whatever other systems it needs, aggregate that data and send it to the client in that first response instead of making several calls from the client and not caching anything on the server, and that approach. So the application server can interact with CMS, search, and any other applications that you have. There are some potential implications for JSX, but that's beyond the scope of this presentation. And that's really more about ASP.NET than headless content management or anything that I have to talk about. So, and I don't even really know what JSX is, but it looked ugly. It looks XML-ish. So the application server can respond to webhooks by managing caches. So when the content management system calls the webhook on the content delivery tier, it can cache the data. It can populate event systems. So the content delivery tier can put that data onto a message bus. It can invoke webhooks on the search engine or any other systems, or do whatever needs to be done on the back end. So really, when you're doing mock, instead of building your product on the vendor's platform, you are building kind of an integration layer. You're composing your own application using services from the various vendors. So if you haven't made that paradigm shift, I mean, it's so significant. We're talking about at least one order of magnitude in development productivity improvement. So the application server can render the JSON to markup. So if we want to pre-process that JSON to markup and store it on the server, we can do that when the data comes to the CMS. So we can render it on the server side. We can even push rendered HTML into the search index, or whatever we want to do with that data. We have wide open options. So we can choose to maintain rendering on the client. And in really extreme cases, or for individual components, we can render the data so it's basically static in the search index or in whatever local cache that we have. And this minimizes or completely avoids file regeneration processes and frequent build processes. So we write a stable set of code that is generic, that accesses data, and then we don't have to rebuild that code when we make changes in the content management environment or publish. And we don't have to synchronize publishing with build or any of the challenges that we can run into there. So the advantages of having an application server, we can employ webhook event-driven content delivery architectures instead of the kind of polling or whatever you want to call it when JavaScript on the client is accessing the CMS. We can minimize vendor API calls. Remember, every time we call the CMS vendor's API, we have to pay for that call in one way or another. So having if I've got millions of clients around the world calling those APIs for no reason, that I could just send them the data I already have cached, it's really should be less expensive. I haven't really looked into pricing on the various models, but it should reduce pricing to reduce API calls from all those clients. And it'll also increase performance, which is advantageous. We can server-side cache the data, and including HTML complete pages if we don't have if we don't have any personalization testing, that kind of stuff, and fragments. So if I have a component that is the same for every page or the same for every user, I can cache that fragment. The first HTTP response we send to the client can include markup style, script, notation, and any other resources except maybe images or media that get embedded in the page. And one of the really key features is that we control the endpoints used by our applications. If I access the CMS directly, then the vendor controls those endpoints, and that has some disadvantages. If I control the endpoints, then I can merge data from multiple systems, manipulate that data, minimize that data, secure that data from the CMS, and that's all before the client retrieves it. And I don't have to give security tokens to the client so that they're allowed to retrieve data from the CMS. So it also, and this is really important, insulates the content delivery tier from the CMS. So now I can write my content delivery tier so that it uses my JSON formats and my endpoints instead of using the vendor's proprietary JSON formats and endpoints, which makes it hard to move off the vendor's platform. So I'm trying to insulate all my code from the specifics of the CMS. If I put that in JavaScript on the client and every page on my site, how am I ever going to move to a different CMS? So that's one of the objectives. So we're minimizing and avoiding distributing the vendor-provided security tokens to our clients, and we continue to use the vendor's CDN. So when I request, whether it's an HTTP endpoint, like a REST call, or an image, the vendor puts that into its CDN so that if a subsequent request for the same thing comes out, it's already cached. So for media, I would still store that in the vendor's CDN because I don't think I'm going to invest and make a better solution than the vendor that's focused on that. And even endpoints. So we can still use the CMS vendor's endpoints if we choose to. Personally, I would never do that. I would never use a vendor-specific JSON format or API call in my front-end code. I think that's probably a mistake. So some of the implications specific to ASP.NET Core. So I thought that ASP.NET Core was going to be impossible with headless. I just had, coming from my background, I just didn't see how it worked. And the truth is that it's exactly the opposite. ASP.NET Core is a perfect fit for headless CMS. The amount of productivity improvement is, I think it's more than one order of magnitude. We also get all the stuff that we get from .NET, including strong typing with compile time error detection and everything else. We have Microsoft doing its research and development and providing tooling like Visual Studio Community. So we have a huge organization that's very committed to this technology, that's documenting it and giving us the tools we need to use it. We also have the ecosystem around .NET. If we have existing .NET applications, it's going to be easier to port them to this kind of architecture than the true, whatever you want to call it, Jamstack headless architecture. It's all scriptable via PowerShell, WSL, Windows Subsystem for Linux, and the .NET command. It's open source and it's free. .NET is free. It's, Microsoft used to be the evil empire, but .NET is not one of those things. It's not embrace, extend, extinguish. It's really pushing the technology forward. And if I would compare Java to .NET in the same way that I would compare XML to JSON. That Java holds you back and .NET enables you. It's cross-platform. You can run, I'm running on Windows, but you can run .NET on Linux, and it is stable. And you can also run it on Apple. I don't know that anybody would, but you could. One of the things that .NET gives us is LINQ, which is called Language Integrated Query, which if you haven't used it, it's another great productivity enhancement and code readability improvement. We have, sorry. We have several different front-end processing technologies. So I'm using a Model View Controller, but you can also use ASP.NET Core Razor Pages or Blazor, which is like using C# in the client. And we get lots of reference architectures and implementations for Jamstack. So people have already done this. Microsoft knows that Jamstack's important. So they're making the investments to make that Jamstack stuff possible. Actually, can you mute me for just a second? I need to cough.
Sure.
I'm back. Am I back?
Yep.
So we get Microsoft doing the investment on it, on support, and they have a strong commitment. I mean, we're 20 years into .NET at this point, and that is Microsoft's future. And it's already been highly tested and optimized for security, stability, and performance. So I'm a .NET, the branding's really weird nowadays, but so ASP.NET Core, the Core is kind of legacy branding that for whatever reason they're keeping with ASP.NET. Right now, what was ASP.NET Core, or what was .NET Core is now just called .NET. So I know the terminology is confusing. I think they should just get rid of Core and call it .NET and call the legacy stuff framework. And then there's the .NET Standard, which is kind of what everything has in common. So a little bit of confusion there, but again, .NET nowadays means .NET 5, which is a derivative of .NET Core. ASP.NET Core sits on top of .NET 5, and they left the Core branding in the title. So we're doing really well on time, I think. But we don't have time for discussion. So just really quickly, if you've done .NET in the past and you're adjusting to Headless CMS, think of the CMS as a UI for editing JSON. That's all it does. And you can embed custom UIs in that UI to do your own JSON formats. You define your content types. You define your plain old CLR objects to represent those content types. You use the vendor's SDK, or you can make your own raw REST calls to retrieve entries from the CMS and deserialize that JSON to your POCOs. So your POCOs are really simple, and I call this kind of the hydration layer. I would put this into one project and have all of my other projects depend on that, so that all of my interactions with the CMS and search are in one project that I can replace most easily. And then all other access is to my custom types. So I don't have any vendor-specific dependencies anywhere but in that one layer. And I want to make minimal use of that the vendor's SDK. The vendors have all these functionalities and things like that, but you don't really want to use them because you don't know which of these vendors are going to be here in 10 years. You really don't. There's a lot of competition in the market, consolidation, and the more dependency you build on a single vendor, the shorter the lifespan of your solution might be. So minimize and centralize the use of vendor-specific APIs and SDKs. Embed your custom user interfaces in the CMS. And when you need to extend and integrate you do that at the CMS UI layer. You should do your extension and integration in general in the content delivery tier or in JavaScript on the client, the visitor. But you can embed custom user interfaces and use webhooks and other things to do your custom processing in the CMS. I'm going to skip Headless and just go to, thank you. So, I haven't done a presentation in like 15 years. I don't even remember. And so Akshay invited me to do this, and I already had most of this content, but I hadn't taken the time to make a presentation about it. And going through the presentation helped me learn and expand my understanding of potential architectures. So my first thanks would be to Conabos for inviting me, Contentstack for paying me and giving me free access to a content management system that I really think is the best headless CMS out there. Algolia, Margot, thank you if you're listening. It's been great experiences with Algolia for search. I don't know Algolia's differentiating factors. I just use query by URL. But the user interface, which I probably should have shown. Did I show that? If I can remember my password. No, it's still there. So let's just take a quick look at the index. There should be only one record in it, and it should be that one page that so I like this. I can actually figure my way around this URL that has, this UI that has so much functionality. But this is basically the object I passed in, and here's.
Can you zoom in, John? It's hard.
Yeah. So this is the JSON that we passed into the search index, and I mentioned the content type property in the URL. So I don't have time to really go through that, but Algolia, thanks. This is my LinkedIn handle. I'm kind of abandoning LinkedIn because the content's getting to be like Facebook and they're embargoing content and stuff. So, but for professional stuff and for contacts, that's a good way to reach me. And then I actually have a blog about a lot of this. It actually talks about 3 different headless CMS vendors and how it looks to use them from .NET and some of their advantages and disadvantages for those. So I recommend taking a look at that. And sorry for using all the time for presentation, but I think we'll go to questions and answers now. And Akshay is going to moderate.
Yep. So thanks everyone for joining. This will all be available on YouTube, LinkedIn, and Facebook as a recorded video. So John, we have some questions coming in.
Okay.
So the first one's from Himadri, who you might know.
Yeah.
In the Sitecore space. So Jamstack is to eliminate web server and render from CDN. John, are you proposing to use web server instead of rendering JSON data? Is his question.
Yeah. So what happens when you use the CDN? Your costs go up because you're using the vendor's CDN and you're paying for each of those requests. You have to be aware of the vendor's intentions, right? The vendor wants you to make maximum use of their services and they want to lock you into their platform. That every vendor out there. So do you want to fall into that trap or do you want to look at alternatives? So what's pushing Jamstack forward? Is server management really that big of a problem for ASP.NET? If I had a really unstable application server, then I would understand that concern and I would do everything with functions because the application server is falling over all the time and I don't want to be responsible for babysitting it. But if I don't have an unstable application server, if I have ASP.NET, why not take advantage of it? It's free. Yeah, I got to maintain some servers, but you got to do that anyway. If you can tell me that you don't have a single server to maintain, I'll be amazed. I don't know of any organization that's like that. So maintaining a Windows ASP.NET IIS application is, or the web server that comes with .NET Core, not a big deal. I'm not talking about standing up SQL Server databases and things like that. I'm just talking about, yeah, I do actually want to have application servers. And again, you can use serverless, but then you get into all sorts of things that well, I can't do caching, at least not in memory. I got to have an external store for caching, and you get into other challenges with serverless. So yeah, I mean, I would recommend an application server. I would not recommend static files on the CDN. I just, come on, that's going backwards. Any other questions? Are we out of time? Did I lose you?
Oh, no, I was on mute. Sorry. The next question is, what are the advantages of Contentstack over Contentful as a headless CMS?
So I would never bash on any competing product. They all have their advantages and disadvantages. So I would start by saying the advantages that I've seen in Contentful, and one is kind of market share or market mindset. Like everybody knows what Contentful is. It's kind of the default headless content management system, probably because of marketing, or I'm not sure what caused it to be out there. Maybe the price point, the other variables. I find the Contentful UI to be difficult. It's got limited field types and it doesn't have modular blocks. I've also had some challenges interacting with Contentful, especially in the early days. They didn't seem very interested in talking to me as a potential partner. So that's my experience, and everybody else could have a different experience, different impression. I also don't really think that their roadmap is very impressive in terms of they're still catching up with Contentstack in a lot of ways, and they don't even have plans to implement some of the things that Contentstack has, and specifically things like modular blocks. So if I look instead at the advantages of Contentstack, it is similar things. It's the people. It's much easier for me to interact with Contentstack. Even before I joined Contentstack, I was evaluating these products. The modular blocks is a big piece of it. I look at everything from a content delivery with .NET perspective. So I'm not looking at workflow capabilities and things like that. A lot of that stuff is just, it's on the RFP, but it never gets done right. And so I don't tend to look at those kind of things. And then I really don't like the way that Contentful stores HTML as JSON. So if you're in Contentful and you want to retrieve an HTML field value, what you get from Contentful is some JSON that you need to convert back to HTML. And that is just the most common use case in a content management system, is to render HTML as HTML. So maybe there are some advantages to that intermediary JSON format, but I don't see them. It costs me more processing time to convert JSON back to HTML, and whatever they think they can do with JSON, I can do with HTML. So if they're doing custom attributes or something like that, I can do that with HTML. And so I don't need that format. So
What if it's used beyond just the web realm? So if it's in a mobile app or a gaming console, things of that sort.
I still don't see any advantages to Contentful over Contentstack other than possibly price and
Okay.
possibly performance. I didn't heavily evaluate performance.
Okay. All right. So the next question is, how does GraphQL impact your approach? Because
I would not use GraphQL. So again, I'm trying to avoid vendor-specific formats. And if I use GraphQL, I've got to construct a vendor-specific query format and deal with a vendor-specific response format, where that response format may differ from the response format that I get from other APIs. That's a nightmare for me. So what can I do with GraphQL? If I have a search engine, why would I ever use GraphQL in the first place? So I think that there are applications of GraphQL. For me, it's not the right technology. I've definitely looked into it. I mean, I can populate a whole CMS repository using GraphQL APIs, but why? Why would I do that? So there may be very specific use cases for GraphQL, but again, I'm trying to avoid vendor-specific code and vendor-specific formats, especially in my HTML pages. So I avoid GraphQL, and I may be wrong about that. I may be, somebody can prove me wrong. It'd be great. But that's where I am.
Okay, so the next question is, instead of using application server, can I build a wrapper using MuleSoft or similar software and use the gateway as the rendering API?
If you have a layer that can make REST API calls to the CMS, or can retrieve webhooks, or can access a message bus, then you can use that technology to build the solution. So I'm not familiar with MuleSoft or the other product that was mentioned, but I would speculate yes. I'd have to do proof of concept on it.
Okay, because I think I've used MuleSoft before. They provide caching. It's like an intermediary security layer so that you hide all your API endpoints. So you go through them, and then you could cache those calls. And
I wouldn't do it. That's just another vendor dependency I don't want to get into.
okay, what are some of the major challenges and limitations to the approach you showed us?
Okay, so the application server is incredibly stable. It's actually my application that's unstable. There's a lot of pieces. So if I were to really want to do the caching at the content delivery tier, I don't really want to use memory. So I need to have some caching technology at that layer to do that. I didn't run into any limitations. I thought that it was completely enabling. I don't know what those limitations would be.
Okay. And if someone were to get started or start looking at things a different way than a traditional calling the vendor's API approach, like how do they even get started? Because I'm assuming they would probably.
I'll give you free consulting, honestly. Like let's schedule a call.
Okay. And then is there any specific reason you chose Algolia and Contentstack over other?
So yeah, so Contentstack, it would be, I mentioned some of the reasons people might have joined late, but it's product capabilities, especially around data modeling, user interface, and the people at the company. At Algolia, the only real differentiator that I felt in my POC was the people at the company. I believe that there are capabilities in the product that I'm not a search guy, so I don't know what they are, but they wouldn't exist unless they had differentiating factors. So that's a separate analysis for me.
Awesome. All right, I think that's all the questions we have so far, John. Thanks again for joining us and helping us present this and your perspective of how you would see yourself implementing using Headless CMS. So thanks again for everyone for joining us. Thanks, John, for taking your precious time to create the presentation and present it. Nice to see you again.
Thank you.
Have a good rest of your day, everyone.
Bye.